Alright, question 2. Read the proof below carefully, then fill in each blank with the best answer. Given that ABCD is a parallelogram, prove that angle A is congruent to angle C and angle B is congruent to angle D. Alright, normally I would pull up a duplicate tab of this. I'm noticing though that there's 1, 2, 3 blanks and they're all in the same statement. So I first want to just read through and see if we can decipher this just using the context clues. So on this it says quadrilateral ABCD is a parallelogram, so by definition segment AB is parallel to segment CD and segment AD is parallel to segment BC. Alright, so let's draw that out. Segment AB, if we were to continue that, is parallel to segment CD because parallelograms have parallel opposite sides. So again, you can continue those lines out. And AD is parallel to CB. So there's our set of parallel lines. Postulate 0101 allows the construction of segment AC, which is transversal of both sets of parallel lines. Alright, so here's our transversal. If I can follow it. Right there. The blank theorem then supports the conclusion that angle blank is congruent to angle blank and angle 3 is congruent to angle 4. Okay, so what I'm noticing here is angle 3 is between the pink line and the transversal line and the pink line and the transversal line. And if I were to just look at that right there, here's our parallel lines, here's the transversal, here's the left hand side, here's the right hand side. So notice that one of these angles, angle 3, is on the left, right there, and angle 4 is on the right hand side of that transversal. So they're alternate. And now here's our parallel lines, and this would be between them. So they're alternate interior angles. So this one is alternate interior angles theorem. So right here. I have this page pulled up from the website resources under the announcements tab in our course. It's the first website recommended. So I just had that pulled up from the last question. Now I'm going to notice that the other angles are part of this would be angle 1 and angle 2. Now they, however, run based off of between the blue parallel lines. And that's fine. Are they still alternate interior angles? So let's verify. So angle 1, it's right here. Again, here's our transversal. There's the left, here's the right. So angle 1's on the left hand side, angle 2 is on the right hand side. So they are alternate and they are still running between the parallel lines. So yes, they are still alternate interior angles. They are just based on the different pair of parallel lines. They're based on the segment CD being parallel to segment AB, whereas angle 3 and angle 4 are running again along AD being parallel to CB. So that's how you can look at this diagram. And so the blank would be alternate. Okay, alternate interior angles theorem. I'm not typing theorem because it's already there. And then comma space angle 1 and 2. So just 1, comma, space 2. So that's how you would answer this question.